All right, here we go. Lesson part 2 of 9-1. The first part dealt primarily with what we call second roots or square roots. In this other part of the lesson, we're going to deal with cube roots. So, starting off something simple with negative 128. Again, notice we have a negative this time. Usually that doesn't work with even square roots. But I think we can think of a number here that multiplies 3 times to give me 128. Well, 4 times 4 times 4 is 64. So, but notice if I put negatives, I get negative 64. But negative 4 obviously is too small. 5 times 5 is 125. That's too much. So clearly there's nothing perfectly that works. So could I break it up into two numbers that multiply to give me 128? That's not the same number. So what number divides into 128? Which of these numbers in my list of cubes should we try dividing into 128? Some of you will see that number right away. I'm going to start with 8 and then 27. And so I grab my calculator and I say, does 8 divide into 128? And the answer is no. So then I try 27. And 27 doesn't work either. But 64 does. 64 goes in there twice. So I could do negative 64 times 2. All right, so this is how we're going to simplify a cube root. All right. Now again, we look on my list and I see that I can break this now into two parts. The cube root of 64 and the cube root of 2. This first part, we know if it were just 64, it'd be 8. But because it's negative 64, then my answer is negative 8. And then, again, we don't need to put the time sign. I can just put the cube root. Now I've got to make sure this 3 is small, higher up, next to my radical. And then put the 2 inside there. All right, so there is my answer in simplified form. I had a huge number inside. Now there's a smaller number inside. So we've simplified it. And I'm going to do that again now with 125. Again, I see 5 times 5 is 25, but that's not too useful because if I go times, 5 again, I get 125. Oh, that works. So this first part of the problem is going to be really nice. That first part of the answer will be 5. Hurrah! Now let's look at the second part of the answer, x to the 4th. Boo! That's a cube root. Too bad it's not a square root. Are there any cubes hiding in x to the 4th? And the answer is yes. That would be an x cubed times an x to the 1st power. Right? Can't forget the cubes here. So this is just x. So I've got the 5 that came out. I've got the x that came out. And now this piece is stuck. The cube root of x to the 1st. And I don't need to put a power of 1. You certainly can, but you don't need that there. This is a little confusing because this thing looks like it might belong to the x. So you could put a parentheses around them to show that they're not, or just tuck that 3 in tighter. There. So that we know that it's a cube root. Okay? All right. Now we're going to deal with the last 3 or 4 problems. All have ratios, fractions. Remember, we can't have a radical in a denominator, and we can't have a fraction inside of a radical. So the first thing we want to do is kind of break this up into 2 parts. All right, let's look at the bottom part because that's kind of the main problem. I shouldn't have a radical sign down there. So what is the cube root of 216? And if you look back at your list and ask yourself what numbers divide into there, why, look at that. Well, 216 is on there. That's 6 times 6 times 6. So, woo, that's really nice. So the bottom part just becomes 6. And this top part, well, could I rewrite y to the 6ths as y to the 3rds? And the answer is yes. You can write it as 2 of them. So I'm going to put a little radical sign around them. Let me clean that up a little bit so it looks a little bit nicer. All right. And now you will get a y and another y. Okay? So there's one y, there's the other y, over 6. So we end up with y squared over 6. All right? This one won't be quite as nice. Parts of it won't anyways. Again, I think the good strategy here is break this up into 2 separate problems. Now we know that 27 is a perfect square on the bottom, and we know that y cubed is, but 127 is not. All right? Well, let's take the y cubed out. We know that that just becomes y. 127. What can I do with 127? I'm going back at my list, and I'm saying, do any of these numbers divide into 127? And I don't think 8 goes into 127. 27 doesn't. 64, 125. Okay? So 127 is stuck. I think I may have copied that number down wrong. I'm going to go check. Yep, that was supposed to be a 27. Let's erase that and go with 27y cubed. All right. Otherwise, that problem would have been really nasty if it hadn't been. So 27 simplifies out to just 3. 3 times 3 times 3. So we have 3 and a y downstairs. Upstairs, we have 8 cubed, which is 2. And then the x to the 4th. Remember, that won't. So we have an x. And then a cube root of x left inside. When you're almost done, make sure that this and this, nothing can simplify here. Never change, never simplify here. Yeah, but the numbers that come out, make sure that those ratios are simplified and reduced. Now comes the challenging problems because notice here, this problem looks like it's stuck because 3n is so simple. Like, what could possibly come out? Nothing. Well, here's where we have to change the bottom so that we can get rid of the radical sign down there. So the short way to do this is to multiply by itself. Now, remember, to keep the value of the fraction the same, we can only multiply by what I would say is a big 1. Yeah? Notice the value of this fraction is just 1. Okay? So I'm not multiplying by, I'm not changing the value because we're multiplying by 1. So I'm just changing the way it looks. Upstairs, I'm going to combine these two things together because they're both square roots. So I can say the square root of 15n. And that bothers me a little bit that there's a radical up there, but that's okay. Downstairs, we have the square root of 9n squared, which looks like a problem, but it's not. Okay? Come down here. So we have radical 15n over 3n. See how that bottom cleaned up nicely? We got rid of those. All right. Same thing with cubes. Now be careful with cubes. That means this needs to be a perfect cube. So I'm going to multiply again by a nice version of 1. Now a lot of kids think it's just the cube root of 9 times the cube root of 9. But notice 9 times 9 is 81, and 81 is not a perfect cube. If you look back on my list up here, 81's not on this list. So how do I fix that? Well, actually, we're going to multiply by 2 9s. Okay? So I have to add another 9 up there. Now I have 9 cubed in essence, yes? So I have the third root of 9 to the third power. And that's just going to be 9. Upstairs, 9 times 9 is 81. So I have x times the third root of 81. Okay? X times the third root of 81. Okay? And then the last problem here, this is going to be a pesky problem because we've got a minus. And I can't just multiply by radical 3. All right? So I'm going to get rid of that equal sign just for some space. I'm going to change the way it looks. Again, it's going to be a fancy version of 1. But in this case, what fixes it is what we call the conjugate. Now, you recall from last chapter, actually 2 chapters ago, when I multiplied by FOIL, there were 4 multiplications that would occur. So I'm going to do these 4 multiplications step by step. I get 4. Then I get 2 times radical 3. So plus 2 radical 3. Then I get plus. Oop, wrong one. Already did that one. This one. 2 radical 3, but this time a negative. So plus negative 2 radical 3. Oh, those two things are going to cancel each other. That's nicely. And then the last term, radical 3 times radical 3. First of all, notice it's a negative. And we get negative radical 9, which is just a fancy version of 3. So my denominator here ends up to be 4 plus negative 3, which is just 1. Well, that was nice. Upstairs, all I need to do is take 7 times 2 and 7 times radical 3. So the upstairs becomes much easier to work on. We just get 7 times 2 is 14 plus 7 times radical 3. And that's all that changes. So I'm just going to put that down here, 14 plus 7 radical 3. All right. Wow, that was a long lesson. But hopefully you can finish these problems up. Again, these are the worst problems. These are going to be a challenge simplifying these radical expressions. Okay, explaining why these numbers are not simplified, why they need to be rationalized, because their denominators, notice, are problems. Good luck on that, and come see me if you have questions.